Yolan gang, this question on the board was sent to me by C Aggressive on the Loon Gang Reddit. If you guys want your question featured, be sure to head out to the Loon Gang Reddit. Link is in the description. Check it out. So, the question gave us this diagram. X is 4 sine squared y minus 1, with y being between 0 and pi over 2. It says the point P lies on the curve. Verify that K is 2. All right, so that just means that you have y is pi over 3, you're just subbing that in. That's a nice and easy 1 mark question. C Aggressive definitely was not struggling with that one. So we get x is 4 sine squared pi over 3 minus 1. Sine of pi over 3 is a half. No, sorry, it's root 3 over 2. So root 3 over 2, when you square that, you get 3/4. So you get 4 lots of 3/4 minus 1. The 4's cancel, you get 2. All right, that's verified. I guess this is the juicy part. BI is find dy by dx in terms of y. Now this is a Pavan function, aka power function. All right. Whenever you see powers, you immediately think power function. So we have x equals 4, and you're going to rewrite it as sine y to the power 2 minus 1. And we're going to differentiate that with respect to y. So how do we differentiate Pavan functions? The sine y, I call it the angle. You differentiate that first. You always differentiate what's inside the bracket first. Now the 4 is just a multiplier, so 4 lots of. Sine differentiates to cos y, cos e. Then we bring down the power, knock 1 off the power. Bring down the 2, knock 1 off the power, makes it power 1, so it's just sine y. And the 1 just disappears. So here we're just left with 8 cos e sine e. And that's your answer. Oh, we wanted dy by dx. My bad. Okay, so let's be careful with that. We have to actually do 1 over all of that stuff. Usually I do dx dy. I guess examples are trying to be cheeky here. So you have dy dx. They're always trying to get you to lose that 1 mark. Okay, part 2 is convert it back to x. Show that dy by dx is actually that. Now we're going to have to use this to rework it back to x. Now, sine looks like an easy one to do, right? I'm actually going to... how do I want to do this? There's a e... I guess you just go with your instinct, right? So I'm going to rearrange for sine squared y. I'm going to add 1 divided by 4. So I get sine squared y is x plus 1 over 4. X plus 1 over 4. Now, given the range, I'm going to square root both sides, and we're going to take the positive only. Okay? So we get sine of y is root of x plus 1 over 2. Now, in my opinion, the best way to deal with this, because obviously that goes into there, and you can see where that root x plus 1 is going, where it's coming from, is that this thing here is obviously going to be the cos version. The best way to do this, guys, is just use the triangle, okay? Don't be using the identity sine squared plus cos squared is 1. Okay, we're going to look at this triangle. The angle is y. Sine is opposite over the hypotenuse. So the adjacent side is going to be 2 squared, 4 minus this whole thing squared, which is just x plus 1. Okay, which becomes 4 minus x minus 1, which is 3 minus x. Okay, so this is just root 3 minus x. Now you can see where that's coming from. So cos e is a over h. Therefore, dy dx is 1 over 8 lots of cos e. Let's do the other one first because of the order they did. That's just me being, I don't know, I don't want to say the word I'm thinking of. So the 2's are 4, cancels the 8. So we get dy dx is 1 over 2 root x plus 1 root 3 minus x. And that's shown Cool. That's an interesting question. I've actually never done a problem like that before, where you have this kind of implicit differentiation. It's not really implicit, but inverse trig functions. It says the normal to the curve at P cuts the x-axis at N. So we have some normal here. That normal crosses the x-axis at N. Find the exact area of triangle OPN, where O is the origin. So here, OPN. Okay. Well, I think the best way to do that is to just do base times height, where the height here is pi over 3. We need to work out what n is, and then we can just, once we have that x coordinate, that's done. So let's work out what the, whenever they say normal, I'm thinking about finding the equation of the line, right? So we're doing the normal at P. Yeah, we're going to sub in the x value, which is 2, into here. Yeah, so we're going to find dy by dx at 2. We get 1 over 2 root 2 plus 1 is 3. Root 3 minus 2 is 1. Right? That's correct, isn't it? I think something don't seem right. But we're subbing in k is 2, right? So 2, 3, 3, yeah. Okay, cool. So you get 1 over 2 root 3 times top and bottom by... Actually, do you know what? I'm not going to do that. The reason for that is I'm going to do the negative reciprocal, right? So because I need to do the negative reciprocal, I might as well just leave it like that. So my norm, big up Norman in that. The gradient will be the negative reciprocal of that, which is minus 2 root 3. So I'm going to do y minus the y coordinate of pi over 3 at P is the gradient x minus the x coordinate. Now remember, we don't even need to clean that up. I want to know n, which is where y is 0. I'm just going to sub in y is 0 here. So that goes, the double minus goes, divide by 2. Ooh, divide by 2 root 3, sorry. The 2 root 3 is going to go under. I'm going to get pi over 6 root 3. Is x minus 2? I guess I should really clean that up. So I'm going to add 2 and I'm just going to write it down. So x is that plus 2. And that's this. And I'm timesing it by pi over 3. So I'm doing half of base times height. So therefore, the area is a half of that base length, which I'm now going to start rationalizing. So pi root 3 over, times in top and bottom by root 3. Root 3 times root 3 is 3. 3 times 6, 18. Plus 2. So it's a half of that base times the height of pi over 3. And they clearly want us to expand everything. Mate, that's 2 over 1. So timesing by 18, I get 36. I'm surprised this is only 3 marks. That seems not a reasonable 3 marks, to be honest. But yeah, we get... Let's think about the best way to even represent this. Because the half and the pi over 3, they can make pi over 6. And this is all over 18, right? Then we got pi root 3 plus 36. I guess we just expand everything. So you have pi times pi is pi squared. Pi squared root 3 over whatever 6 times 18 is. What is that? What's 6 times 18? Is it like 122, 144 or something? Probably more. 6 times 18. 108. I was way off. So you got pi. So I'm going to write root 3 over 108. Pi squared plus... Wait, what? Pi squared root 3 over that then yeah, I guess I should just write that as 2 again, right? So that being 2 times pi over 6 is pi over 3, isn't it? Yeah, because I've got 36 over 6 times 18. Yeah, pi over 3. Pi over 3, a third pi. And it gives me that form. Seems right. I can't see any fault in my working out. So yeah. Who was the guy again? It was like C aggressor or something. C aggressive. So hopefully that answers your question. C aggressive. I'm hoping I got it right. But yeah, guys, if you want to submit your own questions, you could head to the Lungang Reddit. I'd really appreciate if you hit the like button and subscribe for more maths content. If you're interested in my A-level maths courses, there is a link in the description. I'll see you guys in the next video. Nice.